substitution nucleophilic unimolecular. What this heading reveals? என்ன சொல்லுது? What this heading reveals? Nucleophile has to be substituted by another nucleophile, right? One nucleophile has to be substituted by another nucleophile, or one nucleophile is coming and substituting the group in a molecule. Then nucleophilic substitution, a substitution of nucleophile. One nucleophile is substituting other one. Okay, what it represent? Unimolecular. I can write the reaction. CH3 Cl. Okay, what can happen now if I am making the reaction to happen with some kind of OH may be obtained by sodium hydroxide in water. What can happen? This OH minus is replacing the C and it is CH3, right? This is the reaction. Okay, this reaction I am considering it is a nucleophilic substitution. Can you able to accept it, right? முடியுமா முடியாதா? நியூக்ளியோஃபிலிக் சப்ஸ்டியூஷன் நான் சொல்கிறேன். நான் சொன்னால் ஏற்றுக்கவே மாட்டேன். நீ சொன்னால் எதுனாலும் ஏற்றுக்கலாம் சார் அப்படின்றியா? இல்லை நான் வந்து பயங்கர தூக்கத்தில் இருக்கேன், தியானத்தில் இருக்கிறேன், இப்போ எது சொன்னாலும் சரிதான் அப்படி ஏதாவது இருக்கா? Can you able to accept it? It is a nucleophilic substitution, right? Instead of the Cl minus, OH minus is substituting, right? OH minus is getting substituted over there, right? This reaction I can consider as substitution nucleophilic unimolecular. Why this is unimolecular reaction? Actually here I am using two different molecules. Okay, one is the substrate tertiary butyl chloride and another one is sodium hydroxide in aqueous. But the reaction rate depends on the concentration of only one of the substrate. It does not depend on the concentration of the nucleophile. So the reaction is said to be a first order reaction. In addition to that, the rate of the reaction depends on the concentration of only one substrate. So I am considering this is unimolecular reaction. Actually this reaction can happen by two steps that can be explained by mechanism. Okay, what is meant by mechanism? Mechanism nana, what it defines? The occurs, or the logical explanation which defines how the reactions are occurs, how the reactions are taking place. That is your mechanism. Mechanism na பயப்பட வேண்டியதில்லை. If you can able to know the concept, even you can write the mechanism for any molecule, any reactions. Okay, that should possess some logical explanation. That's it. Mechanism what you are writing, that should possess some logical explanation. That's it. But you can make the mechanism. Even you can make the mechanism. Actually this reaction, this unimolecular reaction is taking place by two steps that I can explain with the help of first step, carbocation CH3 the Cl minus can go out and I can make carbocation. This is step 1. Step 2, the same carbocation, when I am treating with OH minus, the negative charge attacks this positive charge and it is making tertiary butyl alcohol. Your first step, formation of carbocation. That step is actually slow step. Whenever you are making some carbocation, that step is slow step. So I can consider that step as rate determining step. Okay, in your first step, the formation of carbocation depends only on the concentration of alkyl halide. What I am using. So I am considering always to define the nature of the reaction. Okay, when the reaction is taking place by more than one step, you have to consider only the slowest step. You could not be able to consider all the steps. You have to consider only the slowest step. Here the slowest step is formation of carbocation. that particular step which is making carbocation, that rate is totally depends on the concentration of alkyl halide. So I am considering it is first order reaction and it is unimolecular reaction. If you want to find out the rate of the reaction, or if you want to find out the type of the reaction, I have to analyze the slowest step. When the reaction is taking place by more than one steps. Now more than one step reaction I have to analyze the rate determining step to determine the rate. Here rate determining step is this slowest step. The formation of carbocation is slowest step. That particular reaction is depends on the concentration of this alkyl halide. So this reaction is said to be first order reaction and this reaction is said to be substitution nucleophilic unimolecular. This one is fast step. Actually it's rate determining step RDS and this one is fast step. This is with respect to the mechanism and we have more information with respect to SN1. After this mechanism, factors affecting SN1 reactions. Factors affecting SN1 reaction. Influencing SN1 reaction. Factors influencing SN1 reaction. Solvent factor, leaving group, nature of the substrate. Okay, these three factors are influencing the SN1 reactions: solvent, leaving group, nature of the substrate. 2016 second phase NEET பாத்தீங்கன்னு வெச்சீங்களா. If you are looking at the NEET phase, NEET question from 2016 second phase, one of the code paper is having the first question, organic question, that shows that which of the following solvent can be used in making SN2 reaction. Actually that was not given both in CBSE as well as state board la. You have only about SN2. In CBSE they will never discuss solvent factors. Okay, but you have the question there. The people can able to take the questions from. Actually, we got a question during 2016 NEET second phase NEET 2016 one code paper is containing question based on the solvent effect. Even though you don't have it in your CBSE or state board, it is much important. Okay, there will be right because it is coming under SN1 reaction, right? SN1 is there in CBSE, so it is coming under SN1 reaction. So they are asking. So whenever you are studying some concept, okay, you search all the possible information concept. That will be very much useful. Book padikadinga. Material given only alone, only the material given, as well as don't study only the CBSE or state board book. In addition to that, you can take the topic and you get what are the possible information you have with related to the topic. Okay, with related to the topic, what all the possible informations are there, that you try to take it, try to collect it. Anyway, we used to give all the informations. Okay, we are here to give the informations. Okay, sir will give no need about that, but even then, okay, that's what I'm telling this. Okay, first one, solvent effect. What is the need of solvent? What is meant by solvent? Solvent. Tell me, what is solvent? What is solvent? What is solvent? What is solvent? Na sir தூங்கிட்டு இருந்தா எழுப்பி விட்டீங்க. What is solvent? What is solvent? Yes, the medium which is dissolving the compounds, right? In case of sodium chloride solution, what is the solvent? Okay, the medium which is dissolving the component. If I want to make the to react with each other. This is, you consider, this is the substrate, okay, it is like a solid, and this one is your the sodium hydroxide. I can have it like this. இப்படியே நான் வச்சிடறேன். ரியாக்ஷன் நடக்குமா? 100 நாள் ஆனாலும் நடக்காது, 100 வருஷம் ஆனாலும் நடக்காது, அப்படிதானே? The reaction won't happen, right? If I want to make the reaction, what I have to do? I have to make the collision between the molecule. Okay, I have to do the collision between the molecule, right? In order to make the collision between the molecule, I have to dissolve the molecule in the solvent. I have to dissolve the molecule in the solvent, right? Okay. Okay. I have to dissolve the molecule in the solvent. When I am dissolving the molecule in the solvent, right, what can happen? The molecules can dissociate. When the molecules are dissociating, when I am making the reaction to happen, the molecules gets collide. When the collision is more, it can become a product. Okay. So the solvent is important factor. What is the kind of the solvent I can use it to make SN1 reaction? Now the solvent is polar protic solvent, right? I have to use polar protic solvent. In order to make SN1 reaction, the solvent what I have to use is polar protic solvent. That means the solvent should be highly polar and it has the tendency to give out H plus. Okay, it has the tendency to give out H plus. That means your protons. For example, I can use H2O. H2O can be written like this, right? O H H. I can see the polarity difference between OH. So it can be highly polar. In addition to that, it can give out H plus ions. Okay, this H2O can give out H plus ions. This is a polar protic solvent. Alcohol C2H5OH. It can give out H plus. So it has the ability to give out H plus. So this is a polar protic solvent. Okay, but normally OH alcohol at normal medium it won't give out H plus. Only in presence of active metals it can give out H plus. But since it is having higher polarity, it have the ability to dissociate NaOH to certain extent. Okay, since it is having higher polarity, even though it would not be able to give out H plus readily, it has the tendency to dissociate NaOH to little extent. Okay, so this is coming under polar protic solvent. Yeah, everyone will know. The polar protic solvent is responsible for making SN1 reaction. Why we have to use polar protic solvent? That's NEET question. We'll be getting the question, why this polar protic solvent can be used? Why the H plus donating solvent I have to use? That's the question. Then I'll discuss why the polar protic solvent can be used. You can write a like why the polar protic solvent can be used in SN1 reaction. Okay. Actually, in this step, I am getting carbocation in first step, right? OH minus is attacking. If I am using polar protic solvent, now for example H2O, you can dissociate like H plus and OH minus, right? This H plus can encapsulate this OH minus. If this H plus is not encapsulating, not surrounding H plus, again it can, this OH minus can be obtained from either NaOH or KOH, right? This OH minus can be obtained by either NaOH or OH minus. So if I am not using this polar protic solvent, this Na plus again accumulate with OH minus, again can combine with OH minus, and it won't allow OH minus to dissociate. That is one factor. And another factor, this counter ion, right? This positive, this is H plus. The polar protic solvent is donating H plus. That H plus is encapsulating OH minus. Okay, right? This H plus is encapsulating OH minus, and it is making, and it is acting as a safeguard towards nucleophile until it reaches this positive charge. In addition to that, this counter ion is surrounding the positive charge. Okay, interaction, this OH minus is encapsulating this positive charge, so that it could not aggregate, right? The Cl minus is going out, right? That Cl minus, yes, the Cl minus is going out. That Cl minus, again, it should not come and attack over there. So it has to be stabilized. Simply I can consider this positive charge has to be stabilized by the counter ion. Okay, in order to make the positive charge species carbocation, in order to increase the stability of the carbocation, in addition to that, in order to make the OH minus to be stable until it reaches the positive charge, your polar protic solvent is very much useful. So your polar protic solvent is very much useful to encapsulate the nucleophile and carbocation until the attack of nucleophile over the positive charge. If I am not using polar solvent, polar protic solvent, I will not get this kind of counter ions, positive and negative ions. Encapsulation is not possible. Encapsulation is not possible, the reactivity can be reduced. The OH minus into the Na plus it can easily join with Na plus and it can become NaOH. If the dissociation is very difficult, OH minus production is less, so it won't attack properly, right? The more amount of OH minus attacking over positive charge is not possible. So we are not getting high yield. Okay, so that possibilities are there, so that we are using polar protic solvent. Mostly they will be using aqueous phase for SN1 reaction. Okay. What can happen sometimes based on the substrate and several other factors, if you are using alcohol, in order to make substitution reaction, some elimination reaction can take place. So mostly they will be using aqueous phase as the polar protic solvent. Okay, mostly they will be using aqueous phase as the polar protic solvent, right? This is with respect to the solvent. You should know that, right? It is used for, simply you can write it in one line. Polar protic solvent is used for stabilizing the nucleophile as well as carbocation. Right? Next one is leaving group. When a group is having higher leaving ability, okay, when a group is having higher leaving ability, for example, I have some tertiary butyl chloride. In addition to that, I have some tertiary butyl iodide. Which one will be a better leaving group? Either Cl or I have to remove. Here Cl has to remove and there I has to leave. So which one is having higher leaving ability? Iodine, because the size is large. So not because of steric hindrance, the force of attraction towards the nucleus will be less. The size is large. Yes, obviously steric hindrance that can make the molecule to move out. Okay, Cl, the size is small, so the nuclear force of attraction will be more. So compared to I, Cl is a poor leaving group. But halogens are having better leaving ability, no doubt. If I am comparing all the halogens, I will be having higher leaving ability than Br2, then Br, then Cl, then F. So leaving ability will be like this order. Based on the leaving group order, I is having better leaving ability than Br, Br is having better leaving ability than Cl, Cl is having better leaving ability than fluorine. Okay, because of the size is large, so the nuclear force of attraction is less, so it can easily come out. So comparatively, which one can make SN1 faster? The molecule which is having I. This is with respect to leaving group. I mean the factors of leaving group. Leaving group as a factor, how it is influencing SN1 reaction. Okay. Then the most important thing is nature of the substrate. Which substrate can make SN1 faster? The nature of the substrate. Which substrate can make SN1 faster? Tertiary. Tertiary is the highest. Tertiary molecule is having highest fastness towards SN1 reaction. Abdiya? Tertiary molecule is having highest potential to make SN1 reaction. Abdiya? Which one can make? Why the tertiary molecules are making SN1 faster, or the tertiary molecules are having highest potential? Tertiary carbocation is more stable. That means if we have something which is more stable than tertiary carbocation, that can make SN1 faster, right? So which one will have more stability than tertiary butyl chloride? Which one can make the intermediate which is more stable than the intermediate formed by tertiary butyl chloride? Therima? So, yes, I'll come. Actually, SN1 reaction, right? If I am considering SN1 reaction, the species which can able to form, or the substrate which can able to form stable carbocation, stable intermediate, then that particular substrate can make the reaction faster, or that particular substrate is having higher potential to make the reaction. So, if I am comparing the alkyl halide, which one can make higher stable intermediate? Now, your benzyl carbocation, benzyl halide can make higher stable intermediate. So, first I will write the order of stability of the intermediate, then I will tell you why these particular intermediates are more stable and why that particular intermediate are less stable. Okay, that I will tell you later. First I will write the order of the intermediate formed by different halides. Okay, right. Stability order of the intermediate formed by different halides. By giving Cl2, it can form CH2 plus. This is benzyl carbocation. It is highly stable. Comparatively, allyl halide, it is forming allyl carbocation. Comparatively, it is less stable. Okay. Compared to this allyl carbocation, if I am getting some tertiary carbocation from tertiary butyl chloride, it is less stable. Okay. Then obviously secondary is less stable, and finally primary is least stable. Compared to methyl is most least stable I can consider. Okay, methyl even I can consider as super primary. Okay, methyl even I can consider as super primary. Why these carbocations are more stable comparatively? Actually, it is possessing positive charge, right? The CH3 plus is possessing positive charge. That means the positive needs electron. This or the electron deficiency is satisfied by this methyl group. How this methyl group can satisfy its electron deficiency, or how this methyl is neutralizing this electron deficiency? Through inductive effect. Inductive effect is nothing but the displacement of electron through the bond. What this methyl can do is, it can pull the electron density towards the carbon. When it is pulling the electron density towards the carbon, the electron deficiency or the positive charge species can get the electron and its deficiency can be satisfied, right? Here I have only one methyl group. Here I have two methyl group. Two methyl group is pulling the electron density towards the carbon atom. So electron deficiency can be reduced to greater extent. Here three methyl group. Three methyl group is releasing the electron density towards the carbon. So more electron density will be there. So electron deficiency can be reduced to greater extent. Actually, in all these cases, only the electron displacement is taking place through the bond. Okay, but here this pi bond having the ability to move towards this bond. Okay, the electron shifting is taking place, right? Okay, when this pi bond moves here, I can get the other resonance structure like this. Okay, again to neutralize this positive charge, this pi bond can come here. So this shifting of electron is taking place here. I mean delocalization of electron is taking place here. So compared to inductive effect, electron சும்மா பிடிச்சி தள்ளுறது ரொம்ப எஃபிஷியண்டாக இருக்குமா இல்லை எலக்ட்ரானே ஷிஃப்ட் ஆகிறது எஃபிஷியண்டாக இருக்குமா? எலக்ட்ரானே ஷிஃப்ட் ஆகிறதால தட் இஸ் மோர் எஃபிஷியன்ட். சரியா? ஸோ ஹியர் த ரெசனன்ஸ் இஸ் தேர், த பை பாண்ட் இஸ் மூவிங். So it is highly stable compared to this one. If I am comparing this one to benzyl, benzyl should be highly stable. Why I am telling is, why I am telling here is, here only one pi bond is there to satisfy the positive charge. But here we have three pi bond. These bonds can delocalize and it can increase the electron density over the carbon. சரியா? இது சிம்பிளா என்ன எனக்கு புரியல சார், I could not able to understand அப்படின்னா I am telling you. ஏன்னா ரொம்ப பயங்கர பசியாக இருக்குன்னு வச்சுக்கோ. நான் மதியம் வீட்டுக்கு போகிறேன், இப்போ கிளாஸ் முடிச்சு சாயந்தரம் வீட்டுக்கு போகிறேன், ஏன்னா ரொம்ப பசியாக இருக்குது, ஏன்னா என்னால் உட்காரவே முடியல அப்படின்னா என்ன பண்ணுவான்? வீட்டில் என்ன பண்ணுவான்? தட்டு முட்டு சாமான் எல்லாம் பறக்குமா பறக்காதா? பறக்கும்ல. சரி, அப்படி பறக்கக்கூடாதுன்றதுக்காக அம்மா என்ன பண்ணுவாங்க, இப்போ தாண்டா சமைச்சிக்கிட்டு இருக்கேன் கொஞ்சம் வெயிட் பண்ணு அப்படின்ட்டு ஒரு 4 வாழைப்பழமோ இல்லை ஒரு ரெண்டு 3 ப்ரெட்டோ இல்லை ஏதாவது ஒரு ஸ்நாக்ஸ் கொடுத்தாங்கன்னு வச்சுக்குவேன், கொஞ்ச நேரம் அமைதியாக இருப்போம்ல. கொஞ்ச நேரம் அமைதியாக இருக்குமா மாட்டோமா? இருக்க மாட்டீங்களா? அப்பயும் நான் சும்மா இருக்க மாட்டேன் சார், இருப்போம்ல. இது ஸ்நாக்ஸ் எல்லாம் இல்லை, நீங்கள் எனக்கு சாப்பாடு கொடுத்தா தான், சாப்பாடு கொடுக்குற வரைக்கும் நீ பசியோடு தான் இருந்தாகணும் அப்படின்னா இது ஒரே ஒரு ப்ரெட்டு கிடைக்குது அப்படின்னா இது ஒரு 2 ப்ரெட்டு, இது வாழைப்பழத்தோட ப்ரெட்டு வாழைப்பழத்தோட கிடைக்குதுன்னா இது எப்படின்னா கொடுக்கறது மட்டும் இல்லை, அதெல்லாம் கொடுத்துட்றாங்க கையில், எடுத்து ஊட்டி விட்றாங்கன்னு வச்சுக்கோ, சாப்பிட்றா அப்படின்னு. அதான் இட் இஸ் ரெசனன்ஸ், ரைட்? கொடுக்கறது மட்டும் இல்லை, வாழைப்பழத்தை உளிச்சு வாயில் வச்சு ஊட்டி விட்றது தான் இஸ் ரெசனன்ஸ். இது ஒரே ஒரு வாழைப்பழத்தை தான் வச்சு ஊட்டி விட்றாங்க. இங்கே we have 3 bananas. ஸோ இட் இஸ் ஹைலி ஸ்டேபிள், ரைட்? பாசிட்டிவ் சார்ஜ்னா இட் இஸ் இன் நீட் ஆஃப் எலக்ட்ரான், ரைட்? தட் நீட் ஆஃப் எலக்ட்ரான்னா நமக்கு ரொம்ப பசியாக இருக்குது, வி நீட் ஃபுட், ரைட்? வி ஹாவ் டு டேக் அவர் ஃபுட். அந்த மாதிரியான சுச்சுவேஷனில் instead of getting food, right? Instead of getting food or until the time to take time for taking prepare food, until preparing food, we have to stabilize. Now to stabilize that, we have to get some snacks. அது மாதிரி தான் it has to stabilize by accepting the negative charge. The negative charge வர வரைக்கும் it is getting some snacks. சரியா? அதாவது okay, that is inductive effect and this one is resonance effect. Electron move ஆகுது, அங்க electron displacement is there. So the substrate which can able to form the more stable intermediate, okay, the substrate which can able to form more stable intermediate can make SN1 reaction faster. Okay.